What's going on, 8th grade? How are we doing? Again, we are talking this week in our very third week, and let me just give you a mention of that. Shout out you guys. Y'all are doing such a good job on this online learning path with like very little training. Y'all are killing it. Nice job. Keep it up. Speaking of killing it, Ohio is doing such a good job of doing their part of trying to keep everybody safe when it comes to coronavirus. So please make sure you stay inside. And if you go outside, make sure you wear a mask. Okay, we want to make sure that you all are being safe and healthy and also not infecting anybody else. Keep washing your hands, wear a mask, okay? We're slowly hearing more and more about how businesses might be reopened and how we're gradually going back to somewhat of a normal life. So maybe I'll get to see you before the end of the school year after all. Who knows, okay? But back to the video. This is our third week of online schooling. And this week, we're going to again be talking about systems of equations. But this time, instead of solving them by graphing, we're going to be solving them by substitution, okay? So taking something and putting it in, plugging it into another piece, okay? So without further ado, here's the video.
All right, 8th grade, how are we doing today? Today, we're going to be solving systems of equations through substitution. Last week, we were solving systems of equations by graphing, and now it's going to be a little bit different. Not as much graphing, but taking a known value and plugging it in or substituting it in to a different location. So, I wanted to start off by actually going through what is substitution. Well, substitution means to plug in or replace a variable with an expression. So I have a little example here down at the bottom. If I were to say that x equals 5 and I were to be given something else like x plus 8 equals something else, I could say, oh, I already know what x equals 5 is. So I know that 5 is the same thing as x. So I can take that 5 and plug it in where my x is. And now this changes to be 5 plus 8, which I know actually becomes 13. But this is just a simple idea of what substitution actually means. So let's go to some steps to actually try to do substitution in order to solve a system of equation. So my steps are, first step, I need to solve for one variable in the equation, or in one equation, okay? This could be solving for my x, solving for y, anything you want, okay? After you solve for one of the variables in your new equation, or in your equation, you need to substitute that variable into the other equation. You then need to solve for a variable in your new equation that you have made. You need to substitute the answer to solve for the other variable, and then you need to check your answer. Okay. Now I know these steps may seem a little bit confusing, but I have a couple of example problems here for us to do. Okay. So the first one, y equals 3x and y equals negative x plus 8. Now the really nice thing about this systems of equations is that they've already solved for one of my variables. They solved for y in both of these cases. They're both saying that y is 3x and y is also negative x plus 8. So what I can do in order to make things a little bit easy is I can actually just set them equal to each other. So I have 3x equals negative x plus 8. And now I'm trying to solve for x here. So I'm going to add by x on both sides. 4x equals 8. Divide by 4. And I know that my x value is 2. Okay? So I know my x value. But now I need to try to solve for my y value. So what I need to do is I need to take this 2 and I'm going to plug it in back into one of my previous equations. So now I'm going to have y equals 3 times 2. So I know that y equals 6. So there I have it. I have my x and my y values. I know that x equals 2 and y equals 6. So my solution, my solution is at the point 2, 6. There we go. Let's try another example. Negative x plus y equals negative 1, and x equals y minus 1. Now, what's really nice about this example, again, is they already solved for one of my variables. In this case, they solved for x. So what I have to do is I have to take this y minus 1 and plug it in here. So I have a negative sign times y minus 1 plus y equals negative 1. So I need to distribute this negative sign through, which is really just a negative 1. So negative 1 times y is negative y. Negative 1 times negative 1 is positive 1. So I get negative y plus 1 plus y equals negative 1. Well, after I rearrange things, I have a negative y and a positive y. So they actually just cancel each other out. And I'm left with 1 equals negative 1. Well, let's think about this. Is there ever a situation where 1 equals negative 1? No, there's not. Which means that in this case, for this system of equation, there is no solution. That's right, we're bringing back one solution, infinitely many solutions, and no solutions. 1 doesn't equal negative 1, so therefore there is no solution to this system of equation. Okay, they are never going to intersect. So let's try this with one more example. Negative y equals negative 2x plus 4, and negative 6x plus 3y equals negative 12. Now I know what you're thinking. They solve for this one variable again. However, it's a little different this time. They solved for negative y, but I don't have a negative y down here. I just have a positive y. So what I need to do is I'm going to solve for positive y. So I have negative y equals negative 2x plus 4. Maybe. There we go. What I'm going to do in order to change this is I'm going to multiply both sides by negative 1. So then I get y equals 2x minus 4. So now I have solved for positive y. So I'm going to take this 2x minus 4 and plug it in here. So I'm going to have negative 6x plus 3 times 2x minus 4 equals negative 12. So I need to distribute here, and I get negative 6x plus 6x minus 12 equals negative 12. Well, again, I have a negative 6x and a positive 6x, so they cancel each other out. And I'm left with negative 12 equals negative 12. Now, I know that negative 12 equals negative 12 all of the time. So this means that my solution is infinitely many solutions. And that's all that I have for you. I will tell you that many times you're going to see something like in our first example where there's just one point that is one solution, okay? But there are going to be times where I have questions that are no solution and are infinitely many solutions. But this is how I go about solving systems of equations.